Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 2 for this Christmas week. And we're going to be talking about something called degree days, and it has to do with energy, both production and consumption, and it also has to do with both heating and cooling. So let's go on ahead and take a look at this terminology, which has been used in the meteorological world for quite some time, and also the heating industry and the cooling industry world. So the definition of a degree day. The assumption is that energy is required to heat homes and businesses when the average temperature is below 65 degrees Fahrenheit. And when I say average temperature, that means the average between the high and the low for a given day. So if the high is 50 and the low is 30, the average temperature is 40, and you look at the difference between that and this base temperature of 65. And that energy is required to cool homes and businesses when the average temperature is above 65 degrees Fahrenheit. So let's look at a couple of examples here. Let's say in the summertime, the high is 90 and the low temperature is 70. That gives us a mean temperature or average temperature of 80 degrees Fahrenheit. So the base temperature is 65. You take 80 minus 65, and it gives you 15 cooling degree days. And again, this is something that energy companies, they sort of have a scale where they can look at these numbers and say, okay, over the course of a week or a season, if we have this many degree days, this is how much energy is likely to be consumed, okay, or this is how much energy is going to be needed, okay? So they know how to interpret these numbers. I'm just simply giving you the formula as to how to compute it. Now, in the wintertime, let's take another example. The high temperature is 40. The overnight low is 20. That means our average temperature for the day is 30. And so you take 65 minus 30, and you get 35 heating degree days. So, again, that correlates with the amount of energy that is likely to be consumed when the average temperature is at 30 degrees. Now, there are instances where at least I feel that this can be very misleading, but luckily this doesn't happen often enough to really mess the interpretation of these numbers up. So let me give you an example here. Let's say it's 50 degrees at midnight and we're in the wintertime, okay, so it's very, very mild. Then an Arctic cold front arrives at 12:01 a.m. and the temperature begins to plummet, okay? So by the time we get to 1 o'clock in the morning, 1 hour later, the temperature has dropped 20 degrees, all the way down to 30 degrees Fahrenheit, and by midnight, the following night, the temperature has fallen all the way down to 10, okay? So the average temperature for the day is the high of 50 and the low of 10. So 50 plus 10 is 60, divided by 2 is 30. So the average temperature for the day is 30, and the difference between that and 65 is 35 heating degree days. However, I would argue that for 96% of the day, okay, for 23 out of the 24 hours, temperatures were below the average of 30. So that average of 30 really didn't tell you how much energy was likely to be consumed on that day or needed to be produced, because of the fact that that high temperature only took place for a fraction of the day and the rest of it was bitterly cold. So on those particular days, and these things do happen, and actually today was sort of an interesting example of that as well, because temperatures started off at the mildest temperatures we had all day long and then simply fell as the day went on. So today was not too dissimilar from the scenario that I've outlined here. But luckily, again, these types of situations don't occur frequently enough so that these numbers then become irrelevant and unusable. So that's a little brief lesson on heating and cooling degree days. And of course, if you have an average temperature of 65, that means you don't have any degree days, either heating or cooling, and that does happen every now and then. And of course, different people have different standards. Like, for instance, maybe 65 is not your base temperature. Maybe you don't turn on the air conditioning until it gets to an average temperature of 70, or something like that. So it can be a very personal thing. All right, that's it for now. Want to wish you all a very, very Merry Christmas and Happy Holidays. Enjoy the weekend. Hope you get a chance to celebrate it with people that are near and dear to your heart. And I will be back with you on Monday as we start the final week of 2022. How in the heck did that happen? But it's coming up. Okay, Merry Christmas, Happy New Year, all that sort of stuff, and we'll talk to you next week. Bye-bye.